Welcome to our Investigating Science series. I'm Francine Taylor Campbell, and today we're looking at planning and conducting scientific investigations, and this is targeting our students at grades 4 to 6. All right, so let's get into our session for today. These are our guiding questions. How do scientists gain scientific knowledge? What is a fair test? And how is this carried out? These are the questions we hope to answer in today's lesson. So, how do scientists gain scientific knowledge? Well, by now you do agree that scientists ask questions. Yes, that is where it starts. And then scientists carry out an investigation to find answers to those questions. And they do this by using what we call the scientific method. Now, these are the steps of the scientific method as you're seeing on your screen. So scientists, they see something around them, they make an observation, and then they question, what's happening here, right? Why is this so? And so they basically create what is called a hypothesis, right? So they make a hypothesis, and we'll get into what that is. And then, of course, they need to prove or disprove that hypothesis by carrying out an investigation. After carrying out that investigation, they now get their results, which they will analyze, right? And then they will share those findings so that we can draw some conclusions. So that is in effect the steps of the scientific method, and we hope to use that particular method in our investigation today. But before we reach there, we want to understand, how do we plan and design those investigations? What is the approach that should be used? All right, so let's see. When we're designing investigations, these are some factors that we want to consider. Again, as mentioned earlier, there must be a question that we're answering. And what is that hypothesis that we're making? So we need a hypothesis statement. What are the variables involved? And we'll understand more of what variables are in a minute. The data to be collected and the method that we're using to form our investigation. All right, so we have a design investigations template that is shown, and it essentially is able to guide you through these steps, right, based on the questions shown. So what are we trying to find out? Very important. You cannot be doing an investigation and not know what you want to find out. And then we take it step by step. What are the things that we're changing in the investigation? What are we measuring? What are we keeping the same? And of course, how will we carry that out? So all of that is shown, and we're going to be using that template to determine how our investigation will be sorted. So let's start with this question. Suppose you were asked, which paper is the best? So you are given a set of different types of papers, and you're asked, which paper is the best? Do you think this is a properly phrased scientific question? Is it a good scientific question? Well, for a question to be used for an investigation, we must be clear as to what we're investigating. So which paper is the best doesn't really tell us anything. Because it could be that I'm looking for some other feature, right? Like how strong it is. Somebody else is looking at how transparent it is. Somebody else is looking at whether or not it can mop up water, whether or not it is absorbent, right? So essentially, we must phrase our questions in such a way that we're clear as to what we're investigating. So let's look at this particular question. We are looking at how does the temperature of the water affect how quickly salt dissolves. So notice that question, we are clear as to what we're doing. How does the temperature of the water affect how quickly the salt dissolves? So before we can get into that, we must develop our hypotheses. And as you can see here, there are some what we call qualities or characteristics of a good hypothesis statement. Right, so as stated before, we have to start with our hypothesis. And so we have to be able to create a basic good hypothesis statement. What is the hypothesis? It is a tentative description of what you think will happen. You haven't done the experiment yet, haven't done the investigation yet, but you think that this will happen. And so it's like a prediction. And the statement that you make must be testable. So if we look back at that question about which paper is the best, we couldn't test it, right? Because there are not enough parameters for us to really do a test. So we must have a statement that is testable. It must be what we say reproducible. So somebody else should be able to carry out the same experiment. It should be able to support or contradict theory. And we can use an if-then statement to construct our hypothesis. That is one way that we can use to construct our hypothesis. And so we're going to be trying to use this in this particular investigation. We also have what is called variables. So for any investigation, right, there are some factors that will affect the investigation, right? There are some factors that will affect the investigation. We call those variables. And so we have different types of variables. So we have our manipulated variable or the independent variable. That is one that we change. Then we have our responding variable or dependent variable, and that is the one that we measure. And it essentially responds, yes, to the change that you make. And then we have our constant variable, which basically remains the same. And we have to set it up like this in order to have a fair test. So back to our question that we're investigating. How does the temperature of water affect how quickly salt dissolves? So what will we need for this investigation? What is our hypothesis statement? What can you predict? You have had experiences with dissolving salt or dissolving sugar before, right? So what do you expect to happen? All right, so let's try to create a hypothesis statement. Does salt dissolve faster in cold or warm water? Think about it. Yes. All right, so from that experience, we could say, using an if-then statement, if the temperature of the water is high, then the salt will dissolve faster. So that is creating a hypothesis statement using this if-then clause, right? So that's one way that we can use. Or you could just make a statement, salt will dissolve faster in hot water than cold water, right? So that is your hypothesis statement. All right, so now we have to find out what variables we will be considering. So what is the manipulated variable? What's that again? What are we changing? So based on the design investigations template, what are we changing in this investigation? What do you think? We're changing the temperature of the water. So the manipulated variable is the temperature of the water. So what are the variables to be considered in this investigation? As mentioned, we have three types of variables: our manipulated variable, our responding variable, and our constant variable. So first question, what would be the manipulated variable? In other words, what are we changing? We're changing the temperature of the water. Beautiful. So the temperature is our manipulated variable. And then we need to consider what is the responding variable, which essentially is what are we measuring? When we change the temperature of the water, what is responding to that change? How quickly the salt dissolves. So the speed at which the salt dissolves. That is our responding verb, and so we would measure the time taken for it to dissolve. And then what is our constant variable, which is really saying what will we keep the same? Yes. And so what we will keep the same is the volume of water. Yes, must be the same. And the amount of salt that we use, the mass of the salt, should also be the same. And we do this in order to have a fair test. So, let's investigate. What will we need for our investigation? All right, as you can see here, we would need to have some salt because, of course, we're looking at how quickly the salt dissolves. We have thermometers, beakers, measuring cylinder, and our water at different temperatures. So we have cold water, room temperature, water at room temperature, and of course, warm water. All right, we need a balance or a scale and something to transfer our salt in order to carry out our investigation. Now, let me say that all of these materials, apparatus, with probably the exception of the scale or the balance, can be found in your primary science kits, which is available at your school and should be used from grades 4 to 6. So, what are the steps that we will take? We will need to use our balance, right, in the first place, to measure out the same amount of salt. So today we're using 5 grams. So I would have gone ahead, right, and measured out 5 grams of salt. And we can demonstrate that for you so that you can see that process. And so we're adding the 5 grams to our containers. And then based on our experiment, we also need to determine the volume of water that we're using. And we're using the same amount of water, all right, which happens to be 100 ml. So you would get your measuring cylinder and pour out that volume of water into your measuring cylinder. So I have gone ahead. I now need to pour out my warm water, but I'll do that in a minute. And when we pour out our water, we are going to be setting up our timer, right? Essentially to check to see how quickly the salt dissolves. All right, I'm going to need to get another container, another measuring cylinder to ensure that we have all the water measured properly. It will be important that we take the temperature of our water. So we have our thermometer, all right? And we will take the temperature of our warm water just to ensure that we can state that temperature because that's what is changing, all right? And we'll also take the temperature of our cold water, all right? So my warm, I'm getting that temperature. We have enough thermometers. We should really measure this before, but we can check the temperature of the water that is at room temperature, all right? and that seems to be about 26, 27 degrees Celsius. All right. And then we want to check our cold water's temperature. That's for our cold water. And that is decreasing at the moment. And basically you will have your thermometer suspended in the water, not touching the sides, not touching the bottom, and give it a few minutes to settle, all right, before you take that temperature. Okay? And so what I'm seeing here is about 17 degrees Celsius. So we can note the temperature of our cold water or warm water. That is now about 37 degrees Celsius, and our room temperature, water at room temperature, was around 20, what was that? 25, 26. All right? Good. So once we have done that, we can now proceed to carry out our investigation. We need to have our stopwatch, by the way. All right? So you would basically record your results in a table like the one shown. So your table will have what type of water you're dealing with: cold, water at room temperature, warm or hot water. Another column will have the mass of salt, which was basically 5 grams, and that we said was the same, it was constant. Volume of water, constant as well, 100 degrees, 100 mils, right? And then of course our temperature, which we measured earlier, 26 degrees for our room temperature water. Our cold water was about 17, and our warm water was about 37 degrees Celsius. And so basically we would now pour our water, add our water to our salt. Let's just transfer this, right? So our warm water or cold water, same volume, water at room temperature, and of course we would have our device to basically measure how fast it dissolves. So you should have your timer ready, right? And we have done this. So we have our timers and it is recording. If you are stirring one, you have to stir the other, right? Good. And you stir it for the same amount of stirs, because you really don't want your stirring to affect one over the other. All right? And you're checking to see how quickly it dissolves, right? So which one do you think will dissolve faster? So from what I have here, you can see that the warm water, salt has already dissolved. Almost dissolved in our water at room temperature. And our cold water, not quite dissolved yet. We still have some solid particles at the bottom, all right? And so we're basically timing to see how quickly the salt dissolves. And so our results would look something like this, as shown on your screen. So same 5 gram mass of salt, 100 mils of water for each beaker, right? And as you can see, the temperatures reported there, similar to what we have, but for the hot water, it took about, yes, you can see the the time there, around 46 seconds, right? Room temperature, over a minute, yes, and of course, our cold water, a bit longer. So what can we conclude from these results, just looking at what is given there? It's obvious that the temperature of the water affected how quickly the salt dissolved. Beautiful. And so we can now write up what is called a science report or an investigation, right? A science investigation report using the template that is shown, which is really, again, tracking what you did. What were you trying to find out? What were your results? What steps did you take? What was your conclusion? And so that is represented there on your report. So let's recap and answer these questions. Why was the same mass of salt and the same volume of water used? Why do you think we did that? Yes, because we have to set up a fair test where we keep some things the same, and so the same mass of salt, same amount of water meant that we could now check to see what really affected how quickly the salt dissolved. So those were kept the same in order to have a fair test. What did we change in this investigation? So we had same amount of water, same mass of salt. We used beakers. We stirred it the same amount, number of times, right? What did we change? The only thing we changed was the temperature of the water. So we had warm or hot water, cold, and water at room temperature. What did we measure? Yes, we were measuring how quickly the salt dissolved. So we had our timer and we were checking to see how quickly they dissolved. And so what did we find out? What can we conclude from this investigation? We can simply conclude that the temperature of the water affected how quickly the salt dissolved. So we found that the salt dissolved faster in hot water than in cold water. And so essentially at a higher level we could actually say the solubility, right? How quickly it dissolved, how soluble it was affected by the temperature. Beautiful. So I hope you will now be able to plan and design your scientific investigations. What did we learn today? Scientists use the scientific method to gain scientific knowledge. A hypothesis statement is basically suggesting to us what will happen, somewhat like a prediction. And in a fair test, we will change only one variable and keep all other variables the same. What else did we learn? The manipulated variable is that variable that is changed, like in our investigation. The responding variable is that variable that we measure, which essentially responds to the change, yes? And the constant variable is that variable that we keep the same. So essentially, this represents our scientific investigation and how we conduct that investigation to answer the question posed by scientists. We have come to the end of our investigation today. I hope you have learned something that will help you to plan and design better investigations in your science classes. Goodbye.